Today we're going to continue our review of our math skills by solving two-step word problems, using rounding to check for reasonable answers, and to look for patterns on a multiplication table. So for the first one, I'd like to look at two-step word problems. And we've been talking about visualizing and retelling, looking for clues, drawing a picture, and then of course reflecting and putting that answer back into the problem. So I want you to continue with those steps as we solve two-step word problems. The first one we're going to look at is number 1. The tour boats at the Laguna can carry 8 passengers. Jacob watched 6 boats float by. I'm thinking that's going to be my first step. One of the boats had 2 empty seats. The others were full. How many passengers, that's my unit, were on the 6 boats? So now I want to visualize that. I'm thinking of boats. I can see these big tour boats with their passengers on them, and there's 6 of them. So if I visualize, I'm just going to say there's 6 boats. 1, 2, 3, 4, 5, 6. Says that they can carry 8. That's how many they can carry if they're full. So I know I've got 8 on each boat. Now that I can see this visualization, I know that I have repeated addition to know, well, how many passengers could they carry on all of those 6 boats? So I could say 8 plus 8 plus 8 plus 8 plus 8. Or because I know repeated addition is the same as multiplication, I would start with there's 6 boats with 8 on each, right? That's my first step. 6 times 8 is 48. I hope you guys remember that. So I'm just going to put 48 there. Now the second step says one of the boats had 2 empty seats. So all of these boats had 8, but this one has minus 2, right? It has 2 empty seats. So 8 minus 2, that would be 6 on this one. So it's going to look a little different. I know the total was 48. If I'm thinking 2 of those are empty, I'm going to take those 2 away to see how many passengers are on the 6 boats. So now I know 6 times 8 is 48. Take 2 away from 48, 47, 46. That gives me 46 passengers. Okay, so in this problem, we had to use multiplication and subtraction. Let's reflect, see if that makes sense. The tour boats at the Laguna can carry 8 passengers. Jacob watched 6 boats float by. One of the boats had 2 empty seats. There were 46 passengers on the 6 boats. That makes sense. Okay, look at number 3. Zoe cut a pan of brownies into 4 rows and 6 columns. She divided, wow, giving it away there. She divided them evenly among the 8 people at her scout meeting. How many brownies, that's going to be my unit, did each person at her scout meeting get? Well, I love brownies. Let's visualize. I can visualize brownies for sure. So I'm thinking there's a pan of brownies, right, with 4 rows. So here's going to be 1 row, 2, 4 rows. So here's my pan with my 4 rows. There's a row, and there's a row. And 6 columns. Remember, columns go up. So I'm going to divide this into thirds, this one into thirds. So I have 6 columns and 4 rows. That's a 4 by 6 array. It's a rectangle. I know that the first step is here because if Zoe cut a pan of brownies into 4 rows and 6 columns, I'm visualizing that. I need to know how many brownies she has before I can answer how many each person at her scout meeting got. So if it's a 4 by 6, I know that's 4 times 6. And then it's telling me she divided those by 8 people. So the first step, 4 times 6. If you don't remember 4 times 6, you can use one of these strategies. You could count by 6s 4 times 6, 12, 18, 24. Or you could count by fours, 4, 8, 12, 16, 20, 24. You could count the squares from your picture to get the answer. You might know 2 times 6 equals 12. So if you did that 2 times, because 2 plus 2 would equal 4, then your answer would be 24 when you add them together. So 4 times 6 is 24, and then divided by 8. How many 8s are in 24? Well, think of it like this. Do your equal shares drawing. 24 is your total. How many 8s are in 24? There's 8, 16, 24. Just count by 8s till you get to the answer. And there's 1, 2, 3 8s. So your answer would be 3 brownies. Boy, that sounds good right now. All right, number 5. Grace, oh, we forgot to reflect. Zoe cut a pan of brownies into 4 rows and 6 columns. She divided them evenly among the 8 people at her scout meeting. Each person got 3 brownies. That makes sense. What if you said each person got 30 brownies? You would know that'd be crazy. There's no way because there's only 24 to start with. Looking at number 5, continue with those steps. Grace made 7 bouquets for the bridesmaids in a wedding. She put 3 roses, 4 tulips, and 2 lilies in each bouquet. How many flowers did she use in all? Okay, so if I wanted to visualize, I have 7 bouquets, so I'm going to just do circles for bouquets. 1, 2, 3, 4, 5, 6. There's my 7 bouquets. 3 roses. Let's do R for roses. 1, 2, 3 roses in each. Just kind of doing a visualization to help me understand what they're asking. So each bouquet has 3 roses, 4 tulips. We'll do T for tulips. And I'll make sure I have 4 in each. Oops, I think I did 5 on that one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we have 2 lilies. Notice how I keep going back to the text. 2 lilies. Now I have a good visualization. It's asking me how many flowers did she use in all. Wow, I could use this picture and just count them all, but that sounds very tedious. And mathematicians are efficient. So I'm first going to say, well, if each one has 3 roses, 4 tulips, and 2 lilies, I think I could add that up. So let's add the 3 plus the 4 plus the 2. I'll know how many are in each bouquet. I could even count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if that's right. 3 plus 4 is 7, plus 2 more makes 9. So each bouquet has 9 flowers in it. And when I look at my picture, I could see that that's true. How many flowers all together did she use? That's what we need to know, in all. So I have 7 bouquets and 9 in each. 9 groups of, or 7 groups of 9, but because of commutative property, we can do it this way. 9 times 7. Let's use our 9s trick. Put your fingers down. Go to the 7th finger. 1, 2, 3, 4, 5, 6, 7. Put that finger down. You should have 63. 6 10s, 3 1s. So all together there's 63 flowers. Let's reflect. Grace made 7 bouquets for the bridesmaids in a wedding. She put 3 roses, 4 tulips, and 2 lilies in each bouquet. She used 63 flowers. Yeah, that sounds right. With 7 bouquets and all those flowers, that works. All right, so remember those steps when you're solving your 2-step word problems. We're also going to look at rounding. We just did rounding, so I'm only going to do 1 problem because we've done that. The directions say use rounding or mental math to decide if the answer is reasonable. Write yes or no, then write an equation and solve the problem to see if you were correct. So So it's the same as problem solving, but we're going to round our numbers. Chelsea's class collected cans of food for their local food pantry. They collected 27 cans on Monday, and there's a key word, 78 cans on Tuesday. Then on Wednesday, they collected 53 cans. How many cans did the class collect on those 3 days? So all together. That tells me with these ands, and when I visualize this, that we're going to add. So I'm going to be adding 27 for Monday, 78 for Tuesday, and 53 for Wednesday. But I've been told to use rounding to see if 158 is a reasonable answer. So let's round to the nearest 10 for all of these. Looking at the digit in the ones place is how we will round. 5 and above, give it a shove. 4 and below, take it down low. Because 27 has a 2 in the tens place, I know I'm between 20 and 30. 7 is above 5, so I have to go to the higher 10, which would be 30. 78 has a 7 in the tens place, so it's between 70 and 80. There's an 8 in the ones place, that's 5 and above, so I'm going to round it up to the higher 10, which is 80. 53 has a 5 in the tens place, that means it's between 50 and 60. Has a 3 in the ones place, so I'm going to say 4 and below, take it down low, so I'm going to keep it at 50. Now I can add those up. 0 plus 0 plus 0 is 0. 3 plus 8, 8, 9, 10, 11. 11 in my head plus 5 more, 11, 12, 13, 14, 15, 16. So 160 is what I got. I think 158, yes, is reasonable. I want to check my work. Now I'm going to actually do the problem. 7 plus 8. Well, I know 7 plus 7 is 14 from my doubles back. So I'll add one more, which makes 15, 16, 17, 18. Put the 8, carry that 1, go to the tens place. 2 plus 1 is 3. Ooh, how nice. 3 plus 7 makes a 10. And then a 10 and a 5, that's nice and easy, makes 15. 158. My answer was correct. So you will see some problems with rounding to check for reasonableness. The last thing you'll see in your assignment today is looking at patterns with 10s, 5s, 9s, and so on, using the multiplication table. So when we look at the multiplication table for 5s and 10s, that's this one, I'm looking at my 10s down here. Let's look at the 10s. I see 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I notice that all of these products end in a 0. That is one pattern. They end in 0, all the products for 10s. But then when I look at the 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, the 5s end in 5 or 0, right? Because every other one has a 5 in the ones place. Every other one has a 0 in the ones place. So I have 10 and 10, 20 and 20. They do relate to the 10s. It just takes a little longer to get to them. Now we have a hundreds chart, or not a hundreds chart, actually a multiplication table for the 9s. When you look at the 9s and 10s, how are they related? So when you do your 9s count bys, you have 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. And then, of course, our 10s are 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. If you look vertically at these products, you will notice that the 9 and the 10 has one more than 9. When you look at 18 and 20, the 20 has 2 more than 18. So it's like 20 minus 2 is 18. Looking at the third one, like 3 times 9 is 27. 3 times 10 is 30. That's 3 difference. There's a difference of 3 with the products. When you do the 4 times 9 is 36, and 4 times 10 is 40, that's a difference of 4 between the products of the 9s and the 10s. So it's like 40 minus 4 is 36. And you will see it continues down the road. That's a pretty cool pattern. like this one for the tens. 10 times 9 is 90. 10 times 10 is 100. 100 minus 10 is 90. So that's a cool pattern there. Also on your twos products, if you go to your twos up here, here are 2, you have 4, you have 6. It's just your count bys are counting by twos. You're skip counting, right? It's repeated addition. Do you see that the 2 products are actually the doubles of the ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you double 1, the product of 1, you get 2. Double 2, you get 4. Double 3, you get 6. Double 4, you get 8. And so on. The same thing, if you look at the product for your 4s or your count bys, what are they the double of? 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Those are your 4s count by. Look at the relationship between the 4s and the 2s count bys. The 4s are double of 2s because 4 is the double of 2. And you will see that with the 6s. Your 6s are the doubles of 3s because 6 is the double of 3. Your 8s are the doubles of 4s because 8 is the double of 4. And the 10s obviously are the doubles of 5s because 10 is the double of 5. So on Think Central, you will be looking at using your skills to solve two-step word problems, using rounding to check for reasonableness, and looking for patterns with a hundreds chart. Be sure to turn it in.